Okay, we've done part 1, we've done part 2, so we'll take a look at part 3 and we can figure out 2 pieces of information. We've already realized that this guy is on our starboard bow. He's the stand-on vessel, we're the give-way vessel. So it's obvious, due to our understanding of the coal regs, that we have to maneuver in order to avoid this guy. But the reality is how much do I have to come to the right or to the left in order to maintain a particular CPA? Now, this CPA can be established by the company, it can be established by the captain's standing orders, whatever it may be, is that he or she may have established this persona non grata area that they don't want the ships to come in, inside the circle, if you will. So what happens is that the captain may say, okay, I don't want any vessels to come within a 2-mile CPA radius of our ship. So here's our badly drawn 2-mile circle here around us, okay? So we have that established. In order to figure out how much of a course change we have to make, essentially what's going to happen is we've got to take this relative motion line that we have here and we've got to push it outside of this circle, all right? Because under its current situation, it's going to be 1.4 nautical miles. So we want to push it to a 2-mile radius outside of our perimeter zone, okay? The other important piece of information is we've got to decide when to do this. Now, when we do that, we have 2 ways of establishing this. We know that our vessel is traveling down the relative motion line, and we know what time the CPA is going to occur when he gets right here at 1427. So we may decide at 1410 or 1412 when to change course. But we're going to have to do a lot of calculation for that, and then distance equals speed times time, and run it down here and put the execution point, okay, which we call MX, okay? But it's far easier in a practical way to just look at your radar scope and say, okay, when this guy gets to, let's say, 3 miles, and he touches the 3-mile range ring that I have on my radar, that's when I'm going to change course. And we're going to call that point MX, or the point of execution. That's when I'm going to change course. So what happens is that becomes our pivot point, and what we're going to do is basically this. We're going to take this relative motion line and we're going to pivot it about MX. And we're going to make it so that it's just going to be tangent to or touch the new required CPA. So I go ahead and take my pencil and I draw in a line. This line is called the NRML, okay? The new relative motion line. And as you can see, all I've done is taken this old relative motion line and I've pivoted it about the point of MX and redrawn it so it's just tangent to my required CPA, whatever that may be. And again, that may come from the captain or the standing orders or the company, okay? Once I have that new relative motion line, what we're going to do is take this line, and go ahead and watch me up here. We're going to take the new relative motion line at that same angle, and we're going to take it back up the relative motion line to M. And we're going to draw that line in the opposite direction, like that. That line becomes the advanced relative motion line, ARML, okay? That's the ARML. Again, I'm taking the new relative motion line and I'm taking it back to my collision avoidance triangle and redrawing it in the opposite direction from M. Now, to help you remember this, okay, now hopefully you like M&M candies, because the way I have guys remember this, as I call it M&M, all right, or M&M candies. You're taking the new relative motion line at mx and you're taking it up to m and drawing it in the opposite direction. It's just a way to remember where to put it, because sometimes people take the new relative motion line and they'll draw it from E or they'll draw it from R, and that does no good. You have to take the new relative motion line and redraw it from M, where then it becomes the advanced relative motion line. Okay, so remember M and M's. Now, once we've done this, okay, we now have to go back to our discussion of our true motion vector, which is represented from E to R. Remember, we're the ones who have to change course. And I discussed earlier in part 1 that you have to remember that this true motion vector orientates from E and can never leave E. So which way are we going to change course? We're going to change course to the starboard or to the right. So we're literally going to take this line represented by E to R, which is our true course and true speed, and we're going to pivot it to the right, because we're literally going to change course to the right. So we literally take this line and move it to the right. Okay? And how do we do that mechanically to make it accurate? Is what you're going to do is take your trusty compass. You're going to take that distance from E to R, because remember, we're not changing our speed. We're only changing course. And you're just going to make an arc, and you go down until that arc cuts through the advanced relative motion line. Okay? You take it and cut it till it goes through the advanced relative motion line. Now, once you do this, okay, now you're actually going to redraw that line in. So take a look at up here. This is basically what I've done, is I've taken this line and I've pivoted it about E, because I'm changing course to the right, and I'm redrawing this line in, okay, like thus, okay? And this is what the line looks like. This angle I've created by taking our course and speed and changing the angle of it without changing the distance, which is our speed, until it touches the ARML. That is going to be our new course to steer. Hence, I have labeled it NC for new course. Okay? And what we do is we take that angle, all right, and I just slide it back up to the center of the plotting sheet, and I go ahead and just put a mark up here, and I read what it is. Okay? It should be around 043 or 44, something like that. Okay? You can tell just graphically it's in that angle. Okay? All right? So that's how we establish our new course to steer. It gives us the angle. So what in reality is what's going to happen here is this guy is traveling down our new relative motion line. Here's his true course and speed. When he hits mx, we're going to change course just as he starts to come into mx. And we're going to change course from 000 to 043. And when we do that, we watch our radar, and he should, if everything was done correctly, travel down this new relative motion line. Then he'll maintain the required CPA at 2 miles that the captain wants, and to keep us a safe distance from that vessel. All right? Now, let's take a look at something pretty interesting here. That is the new course. Now, think with me. Suppose I couldn't change course, but all I could do was slow down for some odd reason. Okay, I'm trying to prove something with the triangle here. So I can't change the direction of this, but in this graph of the triangle that I've drawn up here, does it show me anywhere what the speed would be in order to cause this same reaction here to keep this guy 2 miles?
Is it the distance between E and RML? RML?
Exactly, okay? Because we can't change our direction, if we take and measure this distance right here, that would be the speed change, okay? That would be our new speed. And you can actually measure that with your compass. All you're going to do is take your compass and measure from E where that ARML crosses that line. Because remember, we can't change the angle of it, but if we shorten it and slow down, we'll cause the same transit of RML to the new RML. Now, this is my own labeling. Notice I haven't labeled this point, and I'll do that now. What happens is that this is E to R. When I swing the arc and I move R over here, I like to call this R little c. Now, everybody usually learns this as R prime or R1. But for the sake of clarity, I like to call it R little c for course change, okay? If you're going to slow down and not make a course change, I call this R with little s, okay? This would be our speed reduction in order to maintain our 2-mile CPA. Now, what's really cool about this triangle is this, okay? Say for some reason you can't change course to 043 because of another vessel or there's shoal waters or something's going on. You can do a combination of the two, okay? Notice here that I have the two extremes. Here I didn't change course, but I slowed down. Here I changed course, but I didn't slow down. This is course change only. But say I could change course to 030. So I can literally take my straight edge, okay, find 030, bring it over to the triangle, and draw it from here at 030, okay? Now you take your compass and you measure the distance from here to here, where the ARML crosses that new line. That's how much you would have to slow down. So you'd change course to 030, and you must do a speed change, whatever that is. We'll say it's like 12 knots, just for the sake of discussion, okay? So anywhere in between these two extremes, you have to do both actions. You must change course and change the speed. Okay, you see that? All right, it's pretty neat what the triangle gives you. Okay, this is course change, no speed change. This is speed but no course. Anywhere in between these two, you have to perform both. You have to slow down and change course. This sort of completes the whole event here, where we have gone through parts 1, 2, and 3. We've figured out the priority of CPA distance, bearing, and time. Then we did part 2, where we figured out his course and speed. And then we've done part 3, which we figured out what course we have to change to in order to maintain a required CPA. All right? Questions? Excellent. Let's practice some of these. Very good.